Hi everyone. Hi everyone. This is Irshad, and this video is part of Module 2 project. And in this, we will be covering FedEx supply chain analysis, logistic performance analysis. So, before we deep dive into the logistics, let's see the business context. So, as you all know, this is part of a global logistic operations which operate at a large scale, where even a smaller inefficiencies or delivery or freight cost can translate into various financial losses, SLA breaches, and customer dissatisfaction. So global supply chain is very complex, and even smaller ones can lead to significant damages. And FedEx is such a company which operates at global level, and it operates across multiple countries, regions, different shipping modes, air, ocean, truck, and numerous vendors and fulfillment strategies. So we'll have to be very careful uh, with the operations of the logistics. So the problem statement that we have, despite having a higher shipping volume, logistic performance can suffer due to unstable on-time delivery performance, rising costs without proportional speed benefits, and inconsistent vendor performance, and localized geographical bottlenecks. So that is the problem statement. Uh, the objective that we are going to achieve are how can we assess the delivery reliability, cost inefficiencies, speed versus cost trade-off, and how we can find high-risk vendors and countries and support data-driven operational decision making. So this is the problem statement. These are the problems we have: delivery performance assessing, rising cost, inconsistent vendor and geographical bottlenecks. This is our approach, an analytical approach. First of all, we'll analyze the data and clean the data, and then we'll go to feature engineering with uh, with KPIs relevant to the logistic analysis, such as delivery delay, lead time, cost per kg, freight cost as per the value of the shipping percentage of shipping value. Then we will perform EDA across shipment, vendor, countries, fulfillment strategies, and then we'll generate some insights to support our decision making. So these are the questions we'll be answering: which shipping modes, which shipping drives the majority of delivery failure, which are extremely delay concentrated, which are premium ones, which vendors are and countries represent highest operation risks. So let's dive into it. This is our notebook. As we have already gone through the project summary, let's jump into the notebook. This is the problem statement once again. The FedEx logistic managers high global volumes where delays, lead times, rising cost occur, and the objective is to analyze, evaluate delivery performance, lead time efficiency, and freight cost across shipping modes, vendors. Yeah, that's all. Basically, three things: delivery reliability, delivery inefficiencies, cost drivers, and operation bottlenecks. These are the three core things we have to analyze. So let's understand our data. Start with understanding our data. First of all, let's import the libraries that we need. We are using Pandas, NumPy, Matplotlib, Seaborn, text wrap, and warnings. So let's understand the data, what we have. So we have ID column, project, PQ, PO, country, fulfill via line item. This is a product related ones. And at last we have weight, freight, and line item insurance. So how many do we have rows? We have around 10,000 rows, and each row represents one shipment value, one shipment. So we have 33 columns. So let's understand the data, what type of data types we have. So most of the data types are objects. Here we have date time, which we might have to convert. And here the PQ project related data, and we have price price related, and the numerical columns over here. So let's check the data duplicate. We do not have any duplicate values. Let's see null values. So we do have null values in the dosage, shipping, and line items. So this is basically about the data, and here I have created a function for to create an customized charts for this. Okay, so we have gone through a data set. We have 10,000 columns, 33 rows, and it captures logistical detail, shipping modes, vendors, lots of logistical data and all. Logistical data, product data, weight, price analysis. We have lots of it. Let's understand it. Understand the variables. So these are the variables that we have. These are mostly ID related, and these are the ones related to the project. Vendors, here we have shipping value. These are the date related columns, and these are the product related columns that we have over here, and these are the price related ones. So this is the descriptive statistics of the numerical columns. And let's check how many unique values that we have. We have 10,000 unique values, means 10,000 shipments, 142 projects, PQs, and all. So we have lots of data, but we are not going to use every data for our analysis. It's particularly our analysis based on logistic performance. So we will be tracking only those which are related to logistic performance. So let's do the data cleaning part. Yeah, this is our data FedDF. So I actually wanted to show something, unique values. Yeah, here we have taken the unique values, and as you can see, weight here, weight. There are only 4,688. So, but we have around 10,000 shipments. Where did the values go? So the values are here. CDN14153, ID 686170. So what this basically says, we have the weight kg in the ID number 86170. So we have the weight in it. These are not null values, not incorrect values. We have it. So what we have to do, we have to extract it first of all. So we are creating, first of all, we are creating a data frame called FedEx. We are taking the variables which we have to perform logistic analysis. So we have taken it, then we have standardized it, basically converted to small letters and giving underscores, and then we are performing we are doing the converting into correct data types. These are the date time data types. And yeah, so as you can see, extraction part, I have created a function here. First of all, I have stored it in a duplicate column, and then created a function to extract this C where the data contains, and then the log function where it extracts the reference ID which contains the weight, and in this for loop function it extracts the weight of that and puts it into our variable. So this is doing the same, and similar is the case with freight cost. Yeah, and then we are converting few of them. This freight cost line, converting into numerical columns which were object columns, and at last the filling the null values, treating the null values. Few null values that we had, we have filled it here. FedEx is filled with null 0. And imputing when we are doing importing here, the null values that we have, freight cost, we are doing it with mean, and here the product level width of weight, we are taking the product and its sub classification, and with that we are doing the weight, and then category normalization, and finally checking for duplicates and verifying the column. So this is the final data frame that we are gonna do analysis on. So we are gonna do analysis using some features. We the KPIs which are related to the logistic performance analysis and logistic industry basically. Delivery delay. Delivery delay is the actual date minus expected date, and delivery status, which is early, on time, late, flagging it. This is the lead time, actual date versus PO, sent date, which the date we have sent purchase order to the date we have received the delivery is lead time, and cost per kg, which delivery mode is the costliest, and the freight as percentage of cost. Finally, let's deep dive into the EDA part. EDA, we have first of all have divided into four sections. Number one is overview, delivery reliability, cost to serve analysis, speed cost, and decision support and risks. So let's dive into it. So the logistic performance snapshot. In this, we'll be going through a table which summarizes what we are gonna do. So this is the summary of what we are gonna do. We have total shipments of 10,300 and on-time delivery rate of approximately 88%, which should be probably higher. An average delay of 21 days across the shipping modes, and median delivery delay is 92. And total freight cost is $130 million, 130 million M. So average cost per shipment is around $12,000. So, so this is the summary. So this is the summary. Let's look at what's the trend. What is the trend of shipping modes? Let's see. This is the delivery trend chart. So this is the generic chart. So as you can see, this is mostly stable up to here, 2006, 2009. Then there are kind of fluctuations, lots many. But as of now, it's in an uptrend. Average on time is 89% with noticeable month-to-month fluctuations, and the period of decline suggests an operation instability which requires deeper analysis. So we have seen the trend. Now let's go and check why it is. What are the variables that causes the delivery reliability? So first of all, let's go with how many of them are, on time delivery and all. Let's see. So this is the chart. This represent air charter, ocean, and truck. As you can see, most of them are close to 80, 88%, 89%. And the fastest of them, most accurate is this one, air, and close to 81%, 91% is on time, and this is slightly less. This is slightly less, and this one, truck is the third slowest, and the slowest of them all is this one. But if you see interesting data, on-time delivery, these two are almost stable. But as for late ones, this is the one of the which causes more delays. These two, truck and ocean, these two are relatively on time, more on time. Let's go with deliver. Next one is delivery distribution by shipping mode. Which shipping mode? We have seen this are the shipping delays, but how much are they? So here it is. So the most this is, as we already know, this is the most one with the delivery delays. This to ocean, but as you can see, air, it has higher distribution. It means though there are less number of delivery delay, but the delivery delays, the numbers are very high. Outliers that are very high. And let's see the distribution of them. So as you can see, the delivery delay is not evenly distributed, and it has higher concentration with 15 plus days buckets. The ocean has the highest one, 30 plus days, 9.7%. Mostly it is stable and all. Most data lies in between this 1 to 15 days. So countries which are impacted by the most of them are this one, Congo, South Africa, Mozambique. Let's go to the next section. It covers cost to service, freight cost, which is the costliest of them all. As you can see, this $8, air is the costliest of them all, followed by air charter, truck, and ocean. This is just $1.83 per kg. And let's see cost by shipping mode. This is the variability, the distribution. So air charter, which is the second costliest, has the highest variability. It means its range is very high. The lowest and most stable one is ocean, followed by truck, air and air charter the highest. For freight cost as percentage of shipping value. So let's see. Truck is the highest of them all. And why do we use this as percentage of shipping value means? We have to find whether the logistically when we supply it, which of the shipping modes is the most cost efficient ones to ship the product. So truck appears to be the highest of them all, followed by air charter, and ocean. As you can see, ocean is the slowest, but it is very cheap and the one with very less percentage freight cost. Let's go for ship freight cost for the shipping value. As you can see, this plot scatter plot. This as with the freight cost, as the shipping value, there's a positive correlation between the freight cost and the shipping value. As you can see, the distribution over there. Let's go for speed and cost. This speed versus cost trade-off. I mean, which shipping most travels faster but also equally cost more, which is the best for our analysis. As you can see, the air charter is the fastest and the most expensive one, and truck is the most fast in terms of fast and cost efficient, and air is higher cost but not very slow, but it's kind of relative to the air charter, and the slow but cheap is the ocean one. So this is the speed versus cost trade-off. If you want to ship fast, you would cost higher as well. So let's see the lead time trend by shipping mode. This is relatively volatile one. The lead times stability differs across shipping modes, rising cost, and it indicates risk while shipping mode supports reliable planning and SLA. Let's go for last one. Let's see the vendors, how much vendors that we have over here. So this is the matrix, and it displays which are the high cost, low reliable ones. This is the preferred one. Most of them lies in kind of sweet spot. We have to pick the ones which are over here, and in this place covers the critical vendors which will have to renegotiate our contracts, which are high risk, high cost ones. These are the cost efficient. Most of them lie here. So let's see the last one, fulfillment method comparison. So by the method of delivery, right? So as you can see, on-time delivery is higher for direct drop as in comparison to RDC, but the medium cost is also so kind of similar. It is more accurate, 94% on-time delivery, so it also cost higher, direct correlation. But in terms of average delivery value, average delay, this is also higher. So as we have analyzed, let's check what are the solutions that we can to our business objective. Number one is you have to optimize shipping mode with shipping mode selection by which aligns with our speed, cost, reliability, with urgency, and value. And number one, we have to improve delivery reliability by targeting high delay cost modes, routes, and vendors, and reduce the freight cost with monitoring positive value thresholds with correlation high cost outliers, strengthen the vendor governance with performance per segmentation, prioritized high impact countries and routes, and adaptive balanced fulfillment strategies which combines cost efficiency and service reliability. So this is where we conclude, and this shows the logistic inefficiencies and by applying data-driven decision-making across vendors, geographies, fulfillment methods, and client on-time performance reduces. So by implementing these recommendations, we can get more reliable, cost-efficient, resilient logistic, which aligns with business and customer expectations. So this is the logistic performance analysis. This is Irshad signing off. Hope you like the video.